Okay, so this is going to be a video about the changing states of matter. All right, so matter usually exists in three different states: solid, liquids, and gases. But there's also a fourth state of matter called plasma that exists at extremely high temperatures. Right, and the energy in plasma is so high that the electrons are stripped from the nuclei of the atoms, leaving only charged particles. Okay, so in plasma, the matter doesn't exist as actual atoms anymore. You just have charged nuclei and then individual protons, neutrons, and electrons. Right? And again, the temperature needs to be extremely high for this to occur. Right? And so where this happens is inside stars, but on Earth it happens inside. It can be found within the lightning strike. It can be found within auroras, right? But mostly it's found inside stars. Most stars are made up of plasma, atoms in the plasma state, or matter in the plasma state. Okay, now, because stars are made up of plasma, it's actually the most common state of matter in the universe. This universe contains mostly stars, a lot more stars than it does planets. And that's why it's the most common state of matter in the universe. But on Earth, it's still rather rare. And so because it's rare on Earth, we're going to concentrate more on the solid, liquid, and gas states of matter. Okay, so now we call that matter is made up of atoms. And even though atoms are held together by chemical bonds and other forces, the atoms are in constant motion. Okay, and recall that adding heat energy causes the atoms to vibrate faster. And removing heat energy, or allowing them to cool down, causes atoms to vibrate slower. Okay, so when we're measuring the temperature of a substance, we're actually measuring the movement of the particles, right? So in a thermometer, you'll have like the red alcohol, right? And the alcohol particles you put a thermometer against something that you're wanting to measure the temperature, and that the movement of the particles in the substance that you're measuring will transfer the heat energy to the thermometer. And the alcohol molecules within inside the thermometer will then begin to vibrate. And as they vibrate, they begin to expand. And what we read when we read the thermometer is the expanded um, alcohol within inside the thermometer, and that will tell us the temperature. Okay, there is a temperature called absolute zero. Okay, now this is where all particle motion stops. Right? In astronomy, temperatures approach absolute zero, like in space. And we measure absolute zero on the Kelvin scale. Right? So there are three different scales to measure temperature: Kelvin, Celsius, and Fahrenheit. And Kelvin uses 0 degrees Kelvin is for absolute zero. Right now, the United States uses Fahrenheit scale, but science in the rest of the world uses a Celsius scale. The Celsius scale is based on the freezing and the boiling point of water. Water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. Okay, now you can estimate the temperature conversion between Fahrenheit and Celsius, and there's a real easy way to remember this. You just take the Fahrenheit, whatever it is in Fahrenheit, and divide by 2 and then subtract 32. For instance, room temperature is about 70 degrees. Okay, so if we're going to divide that by 2, we're going to get 35 and then subtract 32. So we get down to about 3 degrees Fahrenheit. So we're just kind of estimating. All right, if you're given it in Fahrenheit um, or if you're given the temperature in Celsius and you want to know what it is in Fahrenheit, then you're going to multiply the Celsius temperature by 2 and then add 32. All right, so if 20 degrees Celsius is room temperature, we're going to multiply by 2. That gives us 40. Add 32. That gets us to 72 degrees Fahrenheit, which is about room temperature. Okay, there's also an easy poem to remember. 30 is warm. All right, that'll get you about 92 degrees. 20 is nice. Right, that's about room temperature, 72. 10's cold, about 42 degrees Fahrenheit, and 0's ice. So 0 is 32 degrees Fahrenheit. Okay. All right, now in solids, the atoms are still vibrating, but they're not vibrating that much, and the atoms are held together very tightly, and the atoms take on a definite shape and a definite volume, and that's the definition of a solid, right? As heat is added, the molecules begin vibrating faster, and that causes the bonds between the water molecules to begin breaking, right? And so they go from this crystallized form into a more fluid nature, which we think of as liquid, that because liquids flow, right? In liquids, the vibrating atoms break enough of the bonds to allow the molecules to be able to slide um, and flow past each other. Right now, as more heat is added to the molecules begin vibrating with enough energy to break completely free of the bonds to become a gas. Right now, when water changes states from a solid to a liquid or a liquid to a gas, the water molecule themselves stay the same. So in ice, it's still a water molecule. When it becomes water, it's still a water molecule. And when it becomes steam, it's still a water molecule. So because no new substances are being formed, changing states of matter, when matter changes phases from solid to liquid to gas and back, it's just a physical change because no new substances are formed. Right now, matter can change states with the addition or removal of thermal energy, which we know of as heat, which we usually call heat. All right. The temperature at which a substance changes from a liquid into a solid is called its freezing point, right? And the freezing point of water is 0 degrees Celsius, right? The temperature at which a substance changes from a solid into a liquid is called its melting point, right? And again, that's at 0 degrees Celsius. So the melting and freezing point actually occur at the same temperature. The only thing that's differing is, are we adding heat to turn it from a solid to a liquid? Are we, in other words, melting it? Or are we removing heat, right? Turning it from a liquid into a solid or freezing it, right? Okay, now we can actually lower the freezing point by adding substances to water. Okay, such as when we add antifreeze or salt. It keeps the water molecules from being able to form hydrogen bonds, so it won't solidify to form an ice. And that's why we add antifreeze to our radiators in the wintertime, so that the water doesn't freeze within the radiator. We put salt down whenever we're expecting snow, because that will help lower the freezing point, so that it needs to be a whole lot colder in order for that water to freeze. And that reduces the amount of ice we have on the road. Now, the water molecules can still freeze, but it just has to be a lot colder. Right, vaporization. Right, so vaporization is when substances change from a liquid state into a gas state. Right, now there are two ways that vaporization can occur. Right, there's evaporation and there's boiling. Right, evaporation occurs at just the surface of a liquid, and the temperature doesn't need to be as high. I mean, obviously, this water is not boiling at 100 degrees Celsius, but it is evaporating. And you see evaporation all the time, even on cold days. And that's because it's just occurring at the surface, and so it doesn't require as much thermal energy to turn from a liquid into a gas. Right now, boiling occurs throughout the entire body of the substance, and that's why you see the bubbles, because the liquid water at the bottom is turning into a gas, and it will bubble up to the top, right? Okay, now the temperature at which a substance changes from a gas into a liquid is called its condensation point, right? So from a gas to a liquid is condensation. Right? And for water, that occurs at 100 degrees Celsius. That's when the water vapor in the air will condensate on the gas. That's how cool it needs to get in order for water to vaporize, or to condensate, rather. Right now, temperature at which a substance changes from a liquid into a gas is called its boiling point. Right? And so the boiling point of water again is 100 degrees Celsius. So the temperature at which water will condensate, oil, or boil is still the same. The only difference is, are you adding thermal energy or are you removing thermal energy? If you're adding thermal energy, it'll go from a liquid to a gas. It'll evaporate or boil. If you are removing thermal energy or cooling it down, it'll turn from a gas into a liquid or condensate. Okay, now there are two other changes in states that aren't as common. We don't see as often, but they do occur, right? So the first one is sublimation, and that occurs when a substance moves directly from a solid into a gas state without ever going through a liquid state. So the best example of this is dry ice, which is frozen carbon dioxide, right? And it doesn't melt into a liquid. That's why it's called dry ice. It just turns directly into a gas. And so, especially around Halloween time, we like to play with it a lot because it will create fog um, around there. And we'll do this in class, so you'll get to play with some dry ice in class. That's sublimation. Right now, deposition also occurs. Now, this occurs when water moves directly from a gas into a solid without going through a liquid state. All right, so this happens on your car windows when you get frost on your windows. When the humidity in the air is high on cold nights, the water vapor will freeze on the windshields through deposition. There's no liquid state that it's going from. It's not like your windshield gets wet first. It's just the water vapor in the air freezing upon the glass. Okay, so here's our different states. If we're going from a solid directly to a gas, it's sublimation. If we're going from a gas directly to a solid, it's deposition. If we're going from a gas to a liquid, it's condensation. If we're going from a liquid to a gas, it's boiling. If we're going from a liquid to a solid, it's melting. If we're going from, from a liquid, from a solid to a liquid, it's melting. And if we're going from a liquid to a solid, it's freezing. All right, so for the I can statements. So I can explain how plasma is the fourth state of matter. Right, so remember that plasma only occurs at very high temperatures, and in plasma, the matter actually exists as particles, charged particles, not as atoms themselves. So you have charged nuclei and charged electrons. Okay, I can explain how changing states between a solid, liquid, and gas is just a physical change. All right, so in order for it to be a chemical change, a new compound is formed. But in the case of changing states, the molecules change states, but the molecules themselves don't change. No new substances are formed. Right? And so that's why it's just a physical change, because no new substances are formed. All right, so I can define the following terms. All right, so for freezing, you're going from a solid to a liquid. Melting, you're going from, freezing, you're going from a liquid to a solid. Melting, you're going from a solid to a liquid. Boiling, you're going from a liquid to a gas. Condensation, you're going from a gas to a liquid. Sublimation, you're going from a solid directly to a gas. Deposition, you're going from a gas directly to a solid. Okay, so that's it for changing states of matter.